So can you see my screen?
Yes.
So I suggest something. Due to how bulky this is, we will divide the numerical integration into two. The first part we are taking now will be about the concept trapezoidal rule and the two Simpsons rule. Yeah. Okay. So let's move on. Can you hear me?
Yes.
So this is what we want to learn how to evaluate numerically. We want to learn how to evaluate this definite integral a to b f of x dx. We have learned this previously, yeah, in our MT. If you have actually learned it, so it's actually the same thing we want to do, but with some other advancements in it. Now, this is what we call definite integration. And funny enough, it is not all integral that you can evaluate. It is not all of them that can be evaluated analytically. Yes, so whenever we come across some, can evaluate analytically, then we consult some numerical approach. Now, pay attention. What does this thing that is saying? What does it mean? What does it mean? Yeah, you want to find the integral of this function f of x between this interval x equal to a and x equal to b. That is, yeah, you want to find the integration between this interval. The interval is this. That is a less than or equal to what? B. That is between these lengths. That's what you want to find, what the integration f of x. And pay attention that what do we even call integration in the first place? Okay, let me just quickly sketch it out so you know what you are doing. Then we move on. Now, see what integration means here. Consider this graph. Let's say the function f of x, after plotting it, we obtain a curve like this. Now, look at this point A and B. Look at them here. Look at A, look at B. Look at A, look at B. Now, if I bring down this region, A and B, check. A is somewhere from here to here like this. Look at A, look at B. Now, pay attention. You see this region bounded by this curve and this length A and B. The area covered in this region is actually this integration we are having here. Again, look at this graph. Look at this graph. The integral that you are looking at here is the area under this graph y equal to f of x. That is, you see the area covered in the you see this region. The area covered in this region is what we refer to as this integral a to b f of x dx. You see that our integration is telling you about the area under a curve. The area under what? Under a curve. That is what integration means. So if you plot this function like this, the area under this region that you are seeing here is what we refer to as what? That's integration that you are looking at. Good. So the numerical approach we are going to be looking at in this first part of this video will be trapezoidal rule. We look at trapezoidal rule. We look at Simpsons 1/3 rule. We look at Simpsons 3/8 rule. So the one we'll be considering later will be Rhomberg integration. Rhomberg integration. So looking at this one later, probably this integration. Okay, let's move on. Now, this is what we want to do. So let's start with trapezoidal rule. Let's start with trapezoidal rule. Okay. So how do we use trapezoidal rule to evaluate this integral a to b f of x dx? So the formula is this: I equal to, look at this delta x, over 2 f naught plus fn, then plus 2 summation j equal to 1 to n minus 1 f of b. Don't worry, I'll tell you what this thing means. It's very, very simple. I'll tell you what it means. I'll start with question with it now, so you don't have to cram this formula. Some textbook will not use h. Let's talk about the width. The width. Now, some of them you see h there. So I might be using h for this. So there's a formula that relates A, B, and H together. What's that formula? Take note that you have B is equals to A plus NH. B equal to A plus NH. So to find N, which is the number of intervals, it will be equal to B minus A H. Yes, so see what you have to know here. So your H delta X, and I'll be using it. Why is some F not Fn? Some book will use that Y not, Yn, Yg. It does not mean everything is the same thing. So look at this formula. So let us solve a question. Are you with me?
Yes.
Okay. So let us solve this simple question here. So let's say we want to evaluate. I'm coming. Give me some second. Okay. Let's say we want to evaluate this integral. Let's say we want to evaluate this integral. I equal to 0 to pi. Sorry. Are you hearing any noise from our background, like in music?
No.
Good. So I have sine x dx. So look at what after we can evaluate this one analytically. We all know the integral of cos x is sine x is what? What integral of sine x? Do you know?
Yes, integral of sine x minus cos x.
Exactly. You know that one already. Nice. So now, see what we have here. We want to solve this thing with trapezoidal. So let's see what we have. Okay. Firstly, look at what they asked you to do. You have to evaluate this. They said using 3 panels. That is, though I'll tell you what this means. Using 3 panels. Then I say, and then include the end correction. So focus on how to use trapezoidal rule and not cramming the formula. Now, solution. So what they asked to do. They said that using 3 panels, which means make sure that your n is equal to 3. That is what it means. And what will be my h? Since I've known my n now, my h will be equal to b minus a over n. If I get h from this side, this is what I have. And what's b and a? You see, a is the lower interval, b is the upper interval. So I have to do pi minus 0 over n. N is 3. So my h is pi over 3. It means that, look at what the h means. You see what it means now. You see that h, it means something. If I draw a table like this, okay, so let's say this is my I or J. So let me say this is my x, and I call this one f of x, and I'll call this one f of x. That's the sine x that we are dealing with. Yeah. Remember that your n is 3. So draw it from 0 to 0, 1, 2, 3. Oh yeah, what's my x naught? Remember, see what look at this xi. Yeah, I have x naught, x1, x2, x3. What will be this x naught? Do you know what it will be? X naught will be like, look at this thing. Where is your interval starting with? What's your lower interval?
0.
That's your x naught. That's where you are starting from. Then remember, see what they are telling you is very easy. It's just like you are here, and Darasimi is here. That's your wife.
Why did you do that?
Yes, because that's the only woman I only see with you. So let me say you are here and Darasimi here, and then I want to separate both of you. I want to separate both of you. I'm like, okay, help me divide both of them. Like, let me start to put let me say 2 divisions between them. So look at it too. You are like going from 0 to pi. Then I ask us to use 3 panel. So you see this h I look for is like what we call the width. That's the difference between one person to another person, till we get to that racine. All together.
Yes.
Okay, let's see. Let us do that. Now you see, this is the width. It means that if I'm having 0, the first person sitting here, the next person, the difference between them should be pi over 3. The next person, you add another pi over 3. What do you have? 2 pi over 3. All together?
Yes.
The next person, add pi over 3. You now have what? Pi. Exactly. So that's why we find, you see, if they don't give you n, they might give you the width. So just take note that this is the formula relating them. This is the formula relating them. Just take note of that. So the width will be telling you the distance between one x and the other x. In fact, you even know the number of columns you are going to draw. That's that for that. So next one, f of x be like, what is sine? You remember that our function is sine x, have you now?
Yes.
Yeah, what is sine 0? 0. What's sine pi over 3? That's 0.866. Let me use completely 0.25. Yes, sine of the game is 0.866 0.25. But to do this thing with pi, set your calculator to what, to radian. Set your calculator to what, to radian. Take those, not degrees, if you are using pi. And sine 180 is what? 0.000. How many smart am I using? 6,000. Exactly. So I've gotten my table. There are some questions whereby they will give you the table. They'll just say you should solve. That one is simple. Why some they will not give you the table? So this one now, there's no table. So you are good to go. All right, so let us label this thing. Now, when you are done, this is what you will now do. You now label this thing. Why not? Remember, some people can say f of x naught is the same thing, okay? So why not? Y1, Y2, Y3. All together? So
Yes.
if you label this way, you will have seen that your n is 3. If you label this way, you see that your n is 3. Okay. After that, what do we do? For trapezoidal rule, I is equals to h over 2. Then what do we do? Don't worry. Forget about the formula now. That long formula I gave you. This long formula that you are seeing here. This one that is here.
Yeah.
Let me tell you what it means in real life. So you not cram the formula. I don't even cram it. So what I do, I'll pick the first and last term, add them together. I'll pick the first and last term, add them together. All together?
Yes.
Then you now say 2 times the rest of the times the addition of the rest. Y1 plus Y2. You are done. That's it. That's what that thing is telling you. That is pick first and last. Then say 2 bracket the remaining one. All of them, the remaining one. Let me say you have Y0, Y1, Y2, Y3, Y4, Y5. What will you do? You say Y0 plus Y5. Have you now?
All right.
Then I say 2 times 2 brackets Y1 plus Y2 plus Y3 plus Y4. Do you understand?
Yes.
I just say Y0 plus Y5. Then you say 2 times the rest. That's trapezoidal rule. So let's go. We have everything. My width is what? What's my width? Pi over what? Pi over 3, Abby. My h.
Pi over 3.
All over 2. What's my Y0? 0. What's my Y this on 0? Then 2 times the rest, 0.866025, 0.866025. Exactly. So my I is equals to pi over 6. So times, what would this one give you like that? You don't like 4 times 0.866025. Because what I have here is like 2 times this, so times 2. Just this calculator. So what would this give you?
3.46.
3799. Confirm them. This is what you have.
Times pi over 6, that's times 30. 10. No. 103.93.
Is that what you have?
Yes, like pi over 6 is 30 now. So
No.
answer is going to be
5 over 6. Okay, wait. Hold on. Sorry, let me. Please check your work again. Maybe.
No, where the issue is this pi over 6. Pi over 6 should, like, let me set my calculator to radian.
It's when you are using trigonometry that you will need radian. You know that pi is 3.142, so you can't have 30. There's something wrong. Yes, you can't have 30. So my answer is 1.81 3799. So that's the value of that integration. Now, for end correction, hello, are you following?
Yes.
You see, for end correction, well, you have not seen this one empty before, but these are like improved version of trapezoidal. You see, for end correction, you need to add this term minus delta x squared all over 12, yeah. Then times f prime of b minus f prime of a. Yeah. If they tell you add end correction, add it. If they don't tell you add to end correction, but if you see that, oh, it is function that you can easily differentiate, find it, it will be like a bonus mark. Do you understand?
Noted.
With this one now, you see that f of x is sin x now. Everybody can differentiate this. Even primary school students now can differentiate it. So f prime of x now what? Cos x, have you now?
Yes.
So that's the f of a. And remember our integral is 0 to pi. So our a is 0, our b is pi. So what is f of 0? F of 0 is what? Sin 0, and that's 0. And what is f of pi? Wait, no. I mean f prime of 0, sorry. I meant to say f prime of 0. Remember, f prime of a. Our a is 0, f prime of 0. Our f prime of 0 is what? Cos 0. Cos 0 is 1. And f prime of pi, that's cos pi. What's cos pi? What's cos pi?
Cos 1.
Is that not minus 1? Check that.
Yes, minus 1.
Good. So everything I've said like that. So these are f prime of a, and these are f prime of b. So, and remember my delta x is this h. Don't forget, I can mix the two together. I just know what I mean. So I have negative h. What is my h? Pi over 3 square divided by 12. Then f of b, that's minus 1 minus f of a is 1. Don't forget this minus and this minus. I mean minus 1 minus 1. So what I have here is minus pi square over 9 times 12, then times minus 2. So those minus will cancel out. So my answer is 2 pi square divided by what? 9 times 12? 108, have you?
Yes.
Yes. Oh yeah, punch this in your calculator. This is your. Yeah, what do you have? Let me close this window. There are some song games in my head. I'm coming. Now I have a perfectly silent system. Oh yeah, what do you have there?
2 pi squared over 108, 3.14 squared.
Is that correct?
0.182.
Okay. So therefore, my integral now with the end correction will now give me that my previous answer, which is this, plus this one that I got here. So don't forget that there is a minus in this thing that you are adding with it too. Hello, do you see? All those cheap so plus 0.182771. And the answer is 1.99659. Nice. That's all on trapezoidal rule. Don't forget the end correction. Is that clear?
Yes, sir.
So the next one are the two Simpsons rule. Yeah. So the Simpsons rule, I'll just solve them for you. I will not include, I will just give you the formula for the end correction if you wish to memorize it. That trapezoidal one is simple. But that don't worry, Sha. Look at Simpsons rule here. Don't worry, I'll tell you how to use it. I'll write the formula for you and I'll interpret the formula when we are solving. You see, Simpsons rule, we have two ways. You see, we have two Simpsons rule. One of them is the 1/3 rule. And the third one is 3/8 rule. You see, let me tell you, well, although when I make research about this rule, these two rules have what they are best at. Wait, have you done CHE engineering kinetics. I mean, reaction kinetics.
I know everything you are talking about.
Wait, have you done 310? CH 310.
Yeah,
You have done 310.
we are doing it current. That's why I said I know everything you are talking about.
You will have done something like this. In fact, let me even tell you, if you focus on this thing very well, you will not cram those formula that I have given you. That's just the fact I'm telling you. You will not cram those formula. So it's very easy. So all this part now, actually, I've done it before. Good. So we use Simpsons one-third rule now mathematically when n is even. This is a personal research on my own. When n is even. And here, we use 3/8 when n is a multiple of 3. All right. Now write the formula. The formula is really, it will be somehow. Let me just solve and go. Abina.
Yes, boss.
Let me just solve that. Now, look at that previous question that we did. That previous question, look at the table. This is the table to that question. That formula is long and we can write it in a simpler way other than using those bigger signs. Yeah, so this is what I have. So I have I, xi, and f of xi, which is that thing. So this is what we have. We have 0, 1, 2, and 3. Okay. So see what we have here. We have 0, 1, 2, 3. So this one is what? We add 0, 0, pi over 3, 2 pi over 3, and pi. And this is 0. Okay, this is what we have. Now pay attention to something. I want to first use one-third rule. Remember, is n even here or not? Let's check. See, y0, y1, y2, y3. Is n even here?
Coming. N is not. Wait, y1, y not 1, 2. N is not even.
It's not even. So,
N
but
is,
your
N
n
is
here is
3.
a multiple of 3. I mean,
Yes, a multiple of 3.
exactly, multiple of 3. So the best one to use for this method is what? Simpsons 3/8 rule. Simpsons
3
what?
over 8 rule.
Yes.
3 over
Tell
8
if
rule.
you check the slide, he used 3 over 8 rule and not one-third rule. It was not even stated, but my personal answer back then in MCH when we were doing this thing that when n is even one-third rule. But what of if a number did not obey the 2, like 5? If n is 5, 5 is not even multiple of 3. The best one to use is just one-third rule. Is what?
1/3 rule.
So this is we are using 3/8 rule here, but let me tell you how to remember the 2 rule. Let me write the 2 rule here. So look at Simpsons one-third rule. Simpsons one-third rule. So see what you will do. This is the integral I is equal to. Remember, it's one-third rule. Abina. So you say 1 over 3 times h. If it is 3/8 rule, you say 3 over 3 times h. You understand? How together? Hello? Wow.
I'm with you. I'm with you. I didn't know I was muted.
Okay, yeah. So one-third rule is 1 over 3. 3/8 rule is 3 over 8. Then this is what you will now do. You will now say, okay, see what you're going to do. Hold on. Firstly, you're going to say what you did for trapezoidal rule. Y naught plus yn. Those last term, you are going to put them here. All together?
Okay. Yes, sir.
You will now do something. Okay, wait. Now come, let me teach you this way. Do you know these dates? I know you will surely know the dates. What do they always do on these dates?
14th, Abby.
Yes, 14th of February. What is done that day? One.
Valentine.
Valentine, thank you, Valentine, thank you. See, if you can remember this Valentine, you have known Simpsons 1/3 rule. What would they do there? See,
It's
14
just
of
1 4 2 4 2 like that, Abby.
wait, hold on, calm down. 1 plus I'm coming in. Let me use different color for this thing for my viewers. Then plus now see 14 or something. Then lastly, you have 2. Then you have 0 2, that's 2. Brackets another. Exactly. So that's what we do. 14 of February. So 14 means that one is the coefficient of the first term, which is y naught plus yn. Nothing multiply them, just 1 multiply them. Then remember I told you something that 1/3 is used for what? When n is what? Even. Have you now?
Yes.
Now, what you will now do is that you will now put the y here that disobey this rule again. You know that it is used when n is even. Have you now? You are now going to write the subscript of y that is not even. Do you understand?
Yes.
Yeah. What are subscript of y that is not even? Y1 is not even. Y2 is even. I will not write it. Y3 is even. Is not even. Altogether.
Yes.
Also, what will I write? Y5.
Y5. Yes.
Write them like that. Exactly. That is y of the one that is not even. That's it. Then what will you now write here? You will now write here the one that obey when n is even. Again, here we disobey when n is even. Why this one we obey when n is even? So what do I write here now? What do I write here now? You now write what? Y2 is even, Y4 is even, Y6 is even, blah 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 blah. That's it. Do you get 1/3 rule now?
Yes, I understand.
That's 1/3 rule. So this one make you remember. That is why if she give you a formula that is not put in this pattern, all those ones that have 4 4 4, bring them together, you get this thing. I don't know, just try and just observe a pattern. If you have a long formula, the best way to memorize them is that observe a pattern. So Simpsons 3/8 rule. So what do we do in 3/8 rule? This is the I equal to. Now, what do we do here? Do we say 1/3h or 3/8h? Since we are looking at 3h rule, we say 3/8h. Out together?
Yes.
Shebi, before we do anything on 14th of February, Shebi, every gift that you want to buy for that, you would have bought it a day before. You're laughing. Okay. Bought it a day before Valentine, and that will give us 13th of February, right?
Yes, sure.
You have to prepare a day before. So she'll not go and serve it breakfast. Now, let's go. So we have y naught plus yn. Then remember I told you 3/8 rule is used for what? When n is a what?
What did you say? 3/8 rule is when n is even.
No.
Sorry, when n is odd, is a multiple of 3.
Thank you very much. When n is a multiple of 3. Good. Now, here you will put the one that will disobey. All together?
Yes.
I see my screen.
Yes, I can see your screen very well.
Okay, good. You put the one that will disobey. Yeah, which one disobey? Yeah, which one disobey when n is not a multiple of 3? Give me numbers that are not multiple of 3. 1 is
4.
not a multiple of 3. No, 2 is not a multiple of 3. Also, 4 is not a multiple of 3. 5 is not a multiple of 7, and so on. While here you will put the one that are multiple of 3, which is y3. What again? Y what?
Y9.
Y what? Y9. 6.
9.
6.
6, yes, then 9. 12.
Yeah. I'm still like that exactly. That is it. Do you get that?
Yeah.
Good. Oh yeah. Since we have done this, let us fire this question. Do you have this table with you?
No, 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 no.
You
Well,
draw it.
just a moment. Just a
Okay.
moment. Just a moment. Just a moment. Come on, come on, come on, come on. Okay. Yeah, let's continue.
All right. Okay, good. So you have done that already. So next, oh yeah, let us now solve that question. So solving the question above.
So I want to confirm something. Is that the only rule that we are going to be looking at?
Yes, this three rule for this class now. But
Okay.
we still have one more. That one, I don't want to mix it with this one. Practice this one first. That one is Romberg integration. It's very long and see, don't let me
Okay,
lie
that
for
one is
you.
what?
Romberg integration is very long. You will see it. It's very, very long.
Okay. Okay.
Yeah.
So I have a question, Charles,
Okay. Okay.
because in CH310 we
Yeah.
wrote the test the day before yesterday, and I made use of I think it's trapezoidal rule, but it's quite different. It is h/2, and
Okay.
then it is in multiples. Is h/2, then uh fx naught plus 2 fx1 plus
Yeah.
2 fx2.
Wait, 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 wait. I'll be showing you everything you are saying here now. I'm coming. Let me show you one by one. You see that it's the same thing you are saying. Oh yeah, let's go. Wait, wait. Let me look at where I did this thing. Hold on. Oh yeah, tell me again. What do you say?
I said, so it started with h/2,
Oh yeah, this is h over two. Let's go.
then fx naught,
Fx naught, which is this. Oh yeah,
then 2 fx1.
this is the two fx1 if I expand it. Let's go.
Okay, yes, then 2 fx2.
It's a two fx2 if I expand it. Let's go.
Yeah. So if I'm ending in 3, then it's going to be just fx3.
Yes. Do you see that?
Yes, okay, I think I understand. Okay.
Yeah.
It was
So that
not I'm seeing it now.
okay, yeah. So if you expand it, you will get the same thing. It's just like different, but this is the way I normally put it that make me remember for years. So I don't change this thing in my memory. Yeah, let's go. Solving the above with 3 over 8 rule. Remember, that's the best rule to use. That's the best rule to use. So yeah, let's go. What do we have? Have you written the table?
Yes, I have the table.
So what do we have? So I say I is equal to yeah. What's my h? Our h is pi over 3, have we?
Yes, pi/3.
Okay, pi over 3 over 8, have we now? Because
Yes.
1 and 3 over 8. Yeah, then let's go. Yeah. One,
1 into
what did
bracket.
we say last time? What is it?
What? I
0
said 1
plus,
into bracket. Why not plus? Yes, 0 plus 0.
plus 13, 13 of February,
Plus
3.
3 into bracket
Mhm.
y1, which is 0.866025.
0.866025.
6025
Uh-huh.
plus
Uh-huh.
y2.
Okay. Wait, oh, are you sure? Is y2? 3 over 8. Yes, yes, yes. The one that is not multiple of 3. Yeah, let's go. What do you have for that one?
0.866025.
866025. What else again? Is that all?
That's all.
Then plus 2. There is no other term that's a multiple of 3. Have you now?
Yes, that's y3.
That's nothing, nothing. 2 times everything 0, 0, 0. We don't have them again. Yeah, let's go.
Yep.
Yeah, how would this one give us? Pi over
Pi
24.
over 24.
This is 1.
0.
What is 0? Yeah. So 3 times that's 6 times 0.866025. This is 4.
0.866025
Pi over 4.
times pi over 24. 0.68017.
Is that a final answer?
Yep. 0.68017.
Wait, hold on. Let me just confirm. Wait, 3/8. Sorry, I'm using pi over 3. Maybe it is 3/8. Remember, 3/8. That's 3/8 times this. Do you see? I omitted that 3.
Ah,
Yes, I omitted that 3. So be careful with it. I'm just saying it now. I omitted that 3. Oh, yeah, no, nothing spoiled. Oh, yeah, multiply that answer by 3. What do you get? That'll be about 2 point something. Let's go.
2.0405.
So by 0 forward. 0.5.
05. 2333.
And so on like that. Good. So 1/3. So that's, in fact, let us see what we get for trapezoidal rule. How do you get for trapezoidal?
If we use trapezoidal for this question, Abby?
Yes, now, yes. 1.99.
1.99. Yep. Approximately 2.0.
Let us do analytical one first. Let us see the one that is the closest. Just as play. The answer is this. Just as play. Analytically. Just as take away. We have I equal to integral 0 to pi sine x dx. I mean,
Yes.
to give me cos minus cos x. I mean, yes.
Yes, minus cos x. 0 to pi.
Which is what? Minus cos pi minus cos 0.
Cos 0.
Plus. Yeah. What does that give me?
Minus cos pi. Come in just a moment.
Wait. There's a mistake in this one. Can call.
The answer is 2.
Are you sure? Okay, wait.
Yes.
I made a mistake here.
Where?
It is integral of sin x. Is it cos x or minus cos x?
Minus cos x.
Okay.
It's correct now.
Okay, what is cos of 0?
Cos 0 is 1.
Okay.
No. Yes, cos 0 is 1.
Okay, let me see minus cos pi minus cos 0. Oh, yeah, what's my answer to this?
No. Okay. Yes, it's going to work this way.
Yes. Yeah,
Cos 180 minus cos 0 minus 2. So times the minus 1. So now be plus 2.
Okay, so our answer is plus 2, Abina.
Exactly.
Oh, yeah, now which of them is now the? You can see very, very close. Very, very close. If I use 1/3 rule to show that 1/3 rule is not really accurate for this, try 1/3 rule. Maybe by yourself. If you use 1/3 rule for this question, 1/3 rule, you'll be having your answer to be 1.814529. You can see. You can also use it for it, but you can see that one, the one that is very, very close. Well, trapezoidal rule is close. 1.99
Yes.
close. Also, this one is close. 3/8. Yeah. So let me give you an share class work making assignment.
Assignment now. How much?
Yeah, no, assignment. So I want to see how today we go, whether we can still take Bloomberg integration today.
I thought you said we were going to take it by night.
Yeah, inshallah. Yeah, no, I'm not sure if I'll go and teach him those jam tutorial today. But anyhow, I'll let you know. Yeah, look at this data. You have x and you have y equal f of x. This 0, 0.2, 0.4, 0.6, 0.8, 1.0, and this 1.2. This 9.6, 9.1, 7.4, 6.8, 1.6, 8.8, 12.2. So the answer, that is, you have to evaluate integral 0 to 1.2 f of x dx using Simpsons rule. Well, yeah, if they leave you to use any Simpsons rule you want, use that rule I give you. If n is even, if n is multiple of 3. Is that clear? When they tell you that use any particular one, don't just stress yourself, use it. But they leave you to just use any Simpsons rule. The best choice is that one I've given you above, and that's the end of today's class.
All right, sir.
Yeah, now good. So I'll send the note to you and the video, inshallah.
All right, sir.
Yeah, now bye. Take care.
Bye-bye. Thank you.